This is a recorded lesson on the box and whisker plot. You will need to recall the concepts that you have learned from our discussion on the measures of central tendency, measures of variability, and the measures of relative position. Now, before we dive into creating the box and whisker plot, we first have to study the quartiles. We say that the three numbers q sub 1, q sub 2, and q sub 3 that partition a ranked data into four approximately equal groups are called the quartiles of the dataset. For example, we have the following dataset. Notice that this is arranged from smallest to largest. Notice also that the numbers 11, 29, and 104 divide our dataset into four approximately equal partitions. These numbers are the quartiles of our set, meaning q sub 1 is 11, q sub 2 is 29, and q sub 3 is 104. We mentioned in the previous lesson that percentiles and quartiles are related to each other. We take note of the following remarks that tell us the relationship between percentiles and the quartiles. The first quartile is the 25th percentile, or q sub 1 equals p sub 25. The second quartile is the 50th percentile, or q sub 2 equals p sub 50. And that the third quartile is the 75th percentile, or q sub 3 equals p sub 75. Aside from getting the 25th, 50th, and 75th percentiles, is there another way of finding the quartiles? Another way of finding the quartiles is using the median procedure. You might find this method easier. Number 1, rank the data. The second step, find the median of the data. This is your q sub 2. The third step is find the median of the data values less than q sub 2. This is your q sub 1. And finally, find the median of the data values more than q sub 2. This is your q sub 3. Let us look at an example. Suppose we have the following table that lists the calories per 100 ml of 25 popular sodas or soft drinks. We are asked to find the quartiles for the given dataset. For our solution, we simply need to follow the steps in the median procedure. Step 1 is arranging the data from smallest to largest. Your table of data values should now look like this. Step 2 is to find q sub 2, which is our median. There are 25 values, so the middle value should be the 13th value in the list. Thus, the median is 43. It is also, by definition, our second quartile, or q sub 2. Step 3 is to find our first and third quartiles, q sub 1 and q sub 3, respectively. In our dataset, there are 12 values less than the median 43, and there are also 12 greater than the median. The median of the data below q sub 2, which is our median 43, is our q sub 1. Since there are 12 values, it must be the average of the 6th and 7th values, so our q sub 1 is 39. On the other hand, the median of the data above q sub 2 is our q sub 3. Since there are also 12 values above q sub 2, again, it is the average of the 6th and 7th values. So our q sub 3 is 51.5. Therefore, our quartiles are q sub 1 equals 39, q sub 2 equals 43, and q sub 3 equals 51.5. Now that we are capable of finding the quartiles, we can now proceed to making our box and whisker plot. But what is a box and whisker plot? Sometimes called a box plot, it provides a visual summary of the set of data that we have. This is because it shows us the median, the first and third quartiles, as well as the minimum and maximum values of a data set. If we create the box and whisker plot from our previous example, this is how it would look like. In our previous example, we find that the minimum and maximum values of the dataset is 26 and 73 respectively. We also computed the three quartiles, 39, 43, and 51.5. Notice that this is called the box and whisker plot because of the box in the middle with two line segments attached to it on either side that look like whiskers.